Greetings everybody, myself Palkumar Pathak and welcome to the Lead Code Problem Solving series. In today's video, we are going to solve a really interesting problem which looks simple at first but has a really nice hidden approach underneath. So we will start by understanding the problem clearly, then start with the solving with the brute force solution step by step and then move to an optimized solution which is the main part of our solution. So let's start by the first part, understanding the problem. So, a question is add digits. We are given a simple problem statement. We are given a simple integer called num, which have stored a single integer, and our task is to repeatedly add its digits till it converts itself to a single digit and then return that single digit. This is a simple task. Okay, let me give an example. For example, we have a 3. So we'll start by adding its digits 3 and 8, which will give us 11. Then again, it's not a single digit number. So we'll add its digits again and again, which is 1 plus 1, which equals 2. Now we have a single digit. So we'll simply stop here and return that single digit 2. So our answer will be 2 for the test case 38. So for this, let's start by going for the brute force approach. So let's think first. What can our brute force approach? What can we do to start and solve this problem for the first part? See, we can do it as you can see, we have a repeated task which we are doing again and again. We are selecting a number, getting its digits and adding it. Okay, this is the task, a small part which we are repeating again and again till we have a single digit, which means that we will be using while loop because we don't have fixed number of iterations. So our first approach will be, we will use a single while loop, but we have also a check that yes, if it's not a single digit, do it again, which means that inside a loop we will also need another while loop which can help us to check if it's not a single digit, then repeat it again, because we have two repeated we can say tasks that we are doing in a nested part. Let me explain it properly. See, we are taking a digit, okay, checking it. If it's not a single digit, then inside that we are extracting the digits and adding it up. Then we are again checking it. If it's not a single digit, then do that part again. Go inside the loop again and then again extract the digits, sum it, and then again check. You would have understood what I'm trying to say. We are taking a number, extracting digits, adding it, and checking it, which means we would be needing two while loops in a nested part. Okay, we will start by a variable temp, obviously, because see, we will be needing the original number at the end for checking. So we need to save that and we can't edit it during the process. So we'll need a temporary variable temp. So we will store num simply we will store. After that, we'll for extracting digits, we will also need another variable called digi. Okay, so we'll declare that too. Okay, which won't have any value for now. Just a second, I think that variable will be needed inside the loop. So before that, let's just first declare a loop where we will be checking if the temp variable which we will be editing during the complete process, if it's not a single digit, then run the loop again. Okay, so inside this we will declare an open variable digi and another variable called temp2, for example. Now this is needed because inside the inner process we also need another variable which will be storing the fresh number. Okay, for example here the 38. Now after extracting the digits of 38 inside the first loop, we will be getting the number 11. Now we also need a variable which will be storing 11 as a fresh digit. For that we also need another temporary variable which I am representing as temp2. Okay, this will be equaling to temp. Okay, temp for now. Okay, after that time for the inner nested loop. Here, we will be checking that if the temp is not equal to 0, till that till that part, we will be extracting the digits from the end to the start, like from last part to the first part, because we are using modulus, which helps us to extract the digits from the end to the start, as you know. Okay, so for that, let's start by using dg. Okay, dg equal to temp to percentage n. Okay, now dg will be having the last digit of the temp2 variable. Okay, last digit of the first number. Like for example, 38. Then in the first iteration, it will be having 8 dg inside that. After that, we will be storing that dg inside temp. Okay. Also, I also forgot another thing. As I mentioned that we will need to store of the fresh number inside another variable. But for that thing, we need to equal the original variable inside the loop. Like temp is our original variable inside the first loop. We need to equal it to 0 so that we can store the fresh number, as I mentioned. So we will be storing temp inside, we will storing digit inside the temp, and then we will be decreasing the temp2's last digit. Okay, I hope you understood what I'm doing. Let me explain one iteration. For example, 38 goes inside the first loop. Okay, now 38, okay, you can see the cursor, right? See the temp equal to 38 for now. Now 38 is greater than 9, so the loop will run. Okay, g is declared. Okay, temp is equal to 0. Just a second, I did a mistake. Okay, I need to keep it above the temp equivalent to 0 so that it can be stored. Okay, so temp will be declared and it will be having 38 as a number inside that. After that, temp will be equal to 0 for storing the fresh number inside temp. Okay, now we will be checking if temp, here also there will be temp2, not temp. Okay, so temp2 is not equal to 0 because temp2 is having 38. Okay, so loop will run. Now dg equal to 38 modulo 10, which means dg will be equal to 38 modulo 10, which is equal to 8. Okay, done. dg will be having 38 now. Now temp which is equal to 0, as you can see, temp is equal to 0 before running the loop, will be equal to temp, which is 0 plus 8. So temp will be having 8 now. Done. After that, we got our last digit, so we don't need it now, so we will simply remove that from the temp2. Okay, so temp2 divided by 10, which will be equal to 3, because 38 by 10 is 3.8, and as it is flowed to like using the CPP's basic property, it will be flowed to 3. So temp2 will be equal to 3. Again, after running the second iteration, temp2 not equal to 0. Yes, 3 is not equal to 0. So again, here it will be 3. 3 modulo 10 is equal to 3, and here instead of 0 we have 8 and 3, so 8 plus 3, temp will be equal to 11, and temp2, which is 3 divided by 10, equal to 0. So yes, now this, after this second iteration, this while loop will not run. Okay, it won't be running, and after because temp2 is equal to 0. And after that, after this completion of a while loop, we will have temp equal to 11 now. Okay, this is our first iteration completed of the main while loop. So now temp is equal to 11, temp2 is equal to 0. Okay, after that, the second iteration of while. Again, because 11 is greater than 9, so this loop will run again. Again, dg will be declared, temp2 will be equal to temp, which means temp2 will be equal to 11. Again, temp2 equal to 0 for storing the fresh digit. After that, again, turn off the inner while loop. Inner while loop starts. Temp2 not equal to 0. Yes, 11 not equal to 0. So, after that, dg equal to temp2 percentage 10. Again, like we can say, repeating the process that I just mentioned, extracting the digits and adding it up to get a fresh number which will be storing in temp. So dg equal to 11 percentage 10, which will be equal to 1. Done. Now temp, which is again 0, plus 1, which equals temp equal to 1. Done. Now temp is equal to 1. Temp2, which is 11 divided by 10, equal to 1.1, which is again flowed to 1. Okay, again, second iteration of the inner loop. 1 not equal to 0. Done. Again, this loop will run. dg equal to 1 percentage 10, which is 1 percentage 10, which is again 1. Temp plus dg, which is here it was 1 plus dg, means 1 plus 1, which will equals to 2. Done. Now temp2, which is 1 divided by 10, is equal to 0.1, which is 0. Now temp2 is equal to 0. So this while will not run because this is false. 0 not equal to 0, no, it's false. So this while loop will be completed now. Again, coming to the completion of the main while loop. So now we have temp equal to 2. Okay, 1 plus 1, 2. We have temp equal to 2. Now temp greater than 9? No. Temp is not, 2 is not greater than 9. So this while loop will also not run, and this iteration, this will be the last iteration of the main while loop also. So after completion of this while loop, we have temp equal to 2. Done. As you can see, we have now converted 38 to a single digit number, which is 2. Our task is completed. We will simply do nothing and return temp. Now you will be thinking that yes, the code is completed and this is our brute force approach. No. What if the test case is itself a single digit number? What if the digit that we are getting as input, it's itself a single digit number, as you can see in the second test case, num equal to 0? It won't run because from the starting iteration itself, 0 is not greater than 9. It will not in the main while loop itself and return 0, which is not gonna work. For that, we will have a condition. Just a second. I think it, because we are declaring temp equal to num outside. Yeah, correct. This edge case that I mentioned just now will run for this code because we are declaring temp outside the main loop, which means if it's a single digit number, this while loop won't run and directly return temp itself, which is again passing this edge case to. Let's see if this brute force approach works for all the complete test cases. So yeah, it's working. It's completely working, as you can see. The code beats 100% of the time complexity. Yeah. So, as you can see, this was the complete brute force approach of our problem, add digits. Okay, now you will be thinking, what's the need for the optimized approach? As it beats 100% of the time complexity, 100% of the solution it beats. What's the need for optimized solution? Yeah, it beats, but again, space complexity is really low. As you can see, it's only 7%. This can't anyway work. Okay, this can't never work. For this, we obviously need an optimized approach. So let's go for the optimized approach now. Now let me tell you something about a concept. The thing which we are doing here, it's what we call digital root. Okay, you can search this in internet. The concept that we are using here for solving this problem is digital root, where our task is to convert a number to a single digit. The task that we are doing, it's called digital root in simple English. Now, let me explain uh, what we are actually doing here is we are just extracting out 9 from a digit and then again doing the same thing again and again. Uh, Let me do it real. Okay. As you can see, for example, we have 38. Now, what we are actually doing in this brute force approach is we are subtracting 9 from the digit. Okay, taking that digit, again subtracting 9 from that digit, taking that digit, again subtracting 9, doing this again and again till the number converts itself to a single digit number. Okay, this is the, for example, backend process. This is the backend process which is happening while we do this thing. When we add digits and check if it's a single digit and then again add digits, the thing which the backend part of this process is this thing that we are extracting a 9 from the number and checking if it's single digit or not. It's not single digit, we are again subtracting 9. This is the actual process which is happening in the backend while in the brute force approach that we just did. Okay, now this, for this process, this complete process where we are again and again a number that we are given as input, we can reduce all this complete part into a single line, which is the number modulo 9, because this is actually what modulo does. The operator modulus provides us the remainder of a number when it's divided by the number that we are using with the modulo. Let me just write this thing. Okay, 38 modulo 9. Okay, now when we do this, what will we get is 9 fours are 36. So 38 modulo 9 is 38 minus 36, which is 2. Now you can see the process that we are doing here, the recurring process of subtracting 9 and again checking if it's single digit or not, subtracting 9 again and again. The final answer that we are getting, which is 2, we just did in a single line by using modulo operator. So the thing which I'm trying to say is, just need to do this in our code. We just need to return the num modulo 9. That's all. We just need to return this thing. But there is a catch. Okay, there is a catch. The catch is that what if the number which is given to us is already a single digit number? If the case is that we won't just returning the modulo 9, we will just return the number itself. If the num is less than 9, okay, then what we will be doing is return the num. That's all. Otherwise, we will be returning 9 itself. Now, there is an edge case for this. Okay, let me show you that edge case too. Okay. The number which we are given is a multiple of 9. Let's say it's 18. Now think, what can be the answer of this? 18 modulo 9. It will be 0, because the remainder of 18 divided by 9 is 0. But for this problem statement, our answer will never be 0, because for 18 it's 8 plus 1, 9, and the answer that we need to return is 9 and not 0. Okay, for solving this problem, that the modulo will give 0 and we need to return 9, we will just do a simple trick. We will just do the trick, which is we will be editing the number, like by doing let me show you. Okay, what we'll be doing is, we won't be doing directly modulo 9. The operation that we are doing here, we won't be doing it directly. We will be doing it in a bit different way. We will first subtract a digit from the given input, then take its modulus with 9 and then add 1. Okay, this will be same for all the numbers. For example, we have 38. What will be happening for 38? 38 minus 1, which is 37. Okay, 37. Now 37 modulo by 9, it will give us 1 because 9 fours are 36 and 37 minus 36 is 1. After that, as I showed you, after doing this complete part, we get 1 and we will just add 1 again. 1 plus 1, which is equal to 2. We got the answer again. For normal inputs, it will work perfectly. For these inputs, which are giving us a wrong answer of 8 by doing modulo, this problem of getting 0 instead of 9, it will be solved by doing this operation. Why? Because after subtracting 1, 17 is no more a multiple of 9. So 17 modulo 9 can't be equal to 0. Okay, it will be equal to 1. Okay, not equal to 1 because 9 to 18 and it will be equal to 8 because 17 minus 9 is 8. 9 ones are 9, 17 minus 9 is 8. So after doing 8, after doing all this, 8 and 8 plus 1 equal to 9. So we have our answer as 8 plus 1 equal to 9. I hope you understand what I'm trying to say. The problem which we were facing by directly doing modulo, it's solved by doing this operation. Again, this is same. I'm just doing it normal. I'm subtracting 1 and adding 1. I'm doing the same thing again, getting to the same part. But the problem that we were facing by the inputs which were divisible by 9, it will be solved by doing this simple operation. Okay, so I think this is an operation because we haven't declared any variable, and thus there will be no space taken, almost no space taken. As you can see, from literally 7% to 77%. And see, it is completely an optimized approach. Space and time complexity both solved properly from start till the end. So this was the complete optimized solution as well as the brute force solution from the add digits for the add digits problem. You can think how to solve an actual problem now. We just don't need to solve it. We need to understand it clearly, that what we are using, how we are doing it, and what we are actually doing in the solution for the problem. I hope you like how I explain and solve the problems, the lead code problems. If you like that, you can like the video and leave a positive comment in the video. And if you have any feedback, literally any feedback, anything you want to say, you can again leave a comment in the video, or you can connect with me personally using the description of this video. Both the codes, brute force approach as well as the optimized approach, the codes are the link to the codes are given in the description of the video, and the links to connect with me socially are also given in the description of the video. If you are interested in these type of tech contents and coding related contents, you can subscribe to my channel and like the videos. Thank you very much for seeing the video. Thank you.